Hi everyone, welcome back to another video. So this is exciting. I've finished my second year of university now, so I'm moving on to my third year after the summer. So I've got 3 months off, and in this 3 month period, I'm going to be planning my final year project, and I'm hopefully going to get started on it and really try and make some strides over these next 3 months. So yeah, really looking forward to it. There's going to be a lot of videos coming up on this channel over the next few months. I got a whole bunch of stuff packed. I've even had people send me stuff, which is really nice of them. But yeah, so in this video, we're going to be going through my final year project, which I didn't end up coming up with any other ideas. I just settled on this idea after I did my last video on this, which you can watch here. I just thought, you know what, this is exciting to make a renewable energy kit, whether it's based on the Raspberry Pi or the Arduino, it doesn't really matter. But to make a renewable energy kit that I can sell after I graduate on Amazon, on other websites, eBay, whatnot, whereby somebody, a hobbyist, a student, is able to actually take the kit and learn how, solar panels, wind turbines, etc. work on an electronics level. So let's get straight into this video. So I've picked my final year project. I've discussed it with my lecturer. So let's go through the plan. So first up, you want to find a gap in the market. And this is what came up when I searched for renewable energy kit and Arduino renewable energy kit. And literally, you've got like some renewable energy stuff for maybe like 5-year-olds, and you just got some random robots. There's nothing. And the same thing when you look on Google as well. There's a huge gap in the electronics online market, and you're going to struggle big time to find any sort of kit that could be used to teach renewable energy in any sort of detailed way, especially on both an electronic component level and also on the Arduino Raspberry Pi level. There's just nothing, sadly. So this is where my final year project comes in. Look at that lovely design. Yeah, so the plan is to make a kit like this. Just imagine a little box that you could open up, and it's going to have some really cool things inside. So the full kit will have, PCBs, components. So the PCBs, I'll design them myself, literally CAD files, develop them, get them printed, in China. If you're a PCB printing company, you want to sponsor me, let me know. Get them printed, and then have all the components as well sourced, put them into individual kits, and then the user would actually develop and build as part of the kit, a solar charge controller, a DC to AC inverter, and also a buck converter. And so the plan is to include a small solar panel in the kit, and then possibly sell an upgraded version of the kit with a wind turbine as well, and also include a battery. So if you have a look over here, this is kind of what I have in mind, whereby I could ship the kit with perf boards, prototype boards, and then the person can literally, using my tutorials, they can build together a whole DIY kit of a charge controller, of a buck converter, etc. And so as part of the project, I'm going to design my own PDF tutorials and then also my own video tutorials as well. And then once the user or the student's done with the entire kit, putting the whole thing together will create, a solar panel that generates electricity, which goes into a charge controller, which charges a battery. And then from that battery, you have an AC low voltage output as well as a DC low voltage output, which will, power the Raspberry Pi or power the Arduino. And I don't know if I'm going to have time for this, but it would be great if I can implement some sort of energy IoT tracking device as well in the kit. But again, not sure about time wise. So since time is limited, my lecturer has advised me to come up with a minimum viable product, an MVP. So this is what I've settled on, which is basically just a solar panel, the charge controller, the battery, an AC low voltage output, a DC output, and then a DC buck converter powering the Raspberry Pi or the Arduino. If you've been following me a while, you probably know I'm the type of guy, I like to dream. So for me, I'm already thinking about, what else can what else can I add to the kit? And I think it's very important that, especially I've got less than a year from now. So literally, if you're talking about from when I start university again, which is in October, so I've got 8 months. So, and honestly, when I tell you, I have no idea how a solar charge controller works at all. No idea how a buck converter works. No idea how a DC to AC inverter works. I mean, I think maybe using diodes, that would be AC to DC using a rectifier. Yeah, literally, I got no idea. So there's a lot for me to learn, and so I need to. It's important to have a minimum viable product, I think. Now I'm putting this here as more of a reminder to myself that there are some there's a certain amount of research that I need to do in order to check on like the laws, safety guidelines, standards, best practices. So one of the things I'm planning on doing is doing everything open source. So I'm thinking to document the whole process on my YouTube channel here, and then actually release all of the files, all the CAD design files, all the code, everything. Just release everything on my GitHub and whatnot. So I'm going to need to check on, like, when you put things on GitHub, you've got different licenses. When you're doing stuff open source, I've heard Dave from EEV blog talk about different open source licenses and standards. So I need to do some more research into that. This is just more of a reminder for me. Some of the stuff that I need to consider going forward as well. So in terms of what the university actually wants from me in terms of requirements, there's basically three things. The first is to create a unique product, which I've definitely, with this idea, I've definitely done. Secondly, to create a product that is for an external client and not for, like, for example, the lecturer. And yeah, definitely this is obviously for an external client. It's going to be for students and hobbyists. So I've met that second requirement as well. And then ideally they want me to actually implement the product as well. And like I said, I think it makes sense that I can put an extreme amount of time into this process, develop an actual product, and get it listed online on Amazon and eBay. And I think it'll be amazing. Imagine for people on my YouTube channel to follow the whole journey and then purchase the kit at the end of it. That's going to be amazing. So yeah, really looking forward to that. And I think, yep, definitely, in terms of these requirements, I should hopefully definitely meet all of them. So let's move on to the project plan. I've broken it into 4 different stages, and I think this is probably a very standardized way of dealing with projects. And so if you're going through your project, I definitely advise this. So to look at it in terms of phases, the first phase being the learning phase, which, as I've said, I know nothing. The second phase being the planning phase. And I think sometimes people can jump straight to the planning phase, and you don't know what you don't know. And so there's a lot, like, for example, there's some videos from Great Scott on YouTube. There's some videos from Andreas, I forgot his name now. That's so bad. But he always says, if you subscribe, you sit in the front row. Andreas Spears? I don't know. I've been subscribed to his channel for such a long time and I don't know his name. That's really bad. But he says, greets to YouTubers, is the guy with the Swiss accent. Him and Great Scott, they have some amazing videos, and when I watch them, I don't understand anything. I don't understand anything. I'm like, this looks great. I get that he's mentioning that he needs to put this circuit here and that thing there, but it goes over my head. So I've bookmarked some of those videos, put them in my watch later, and I'm gonna go through and I'm gonna study those videos and everything that they mention. For example, I'm gonna, like, they have one on the solar charger, right? So I'm gonna watch that video, and then every time they mention something I don't know, I'm gonna write that down. And when I finish the video, there should be a very long list of stuff that I don't know, and then I can go and do my own individual research as to what does it mean, a voltage regulator. Like, I literally don't even know what a voltage regulator is. Once we've moved on from the learning phase, we're going to go to the planning phase, development phase, and testing phase. So I've gone into some detail here. Let's go into it next. So we've got the learning phase. So the first part of my learning phase, I'm going to purchase a whole bunch of different the different parts of the entire kit, right? So the solar charger, the buck converter, the DC to AC inverter, the solar panel. I'm going to purchase the whole thing. I've already purchased it, and then what I'm going to do is I'm going to put it all together and see if I can get the whole thing working as one. And then I'm guessing that, based on what I've already ordered, I know that a lot of it, I'm like, I don't think that is going to work together with that. And so it's a good way of me making sure that, the way that I think that this is going to work is probably going to be very different to how it actually works in the real world. So I've purchased all of the parts. In my next video, hopefully I should just try and build this whole thing, get it all working, and then I should be able to figure out where are my gaps in my understanding. Like, perhaps there's something that I'm missing in that kit. So that's the plan with that. Firstly, to create the entire project using non-DIY commercially available parts. And then the second part of my learning phase is to actually go through and purchase the DIY kits themselves and make each of the components, or make each of the circuits myself, using a soldering iron to solder all of the pieces on. And then that should give me a more of an understanding of what's happening, and make my own, basically, solar charge controller on a PCB component level. And then, yeah, after that, the third stage would be to try and replicate the commercially available product and the DIY kit, but this time using my own sourced components. And hopefully that should give me an idea of how easy it is to source components, what I need, what I don't need. For example, if I need a transformer or whatnot. And I'm assuming that after this 3-step process, I should know a lot, and I think I should then be ready to move on to the planning phase, in which now I can actually go, okay, let's sit down, let's make the schematic for my solar charge controller, let's make the schematic for my buck converter. And from those 3 learning phases there, I should learn enough to a point that I could actually start planning. Because when I look at this now, like this planning phase, from what I know now, there's no way there's no way I'd be able to develop a schematic for anything. I don't even know what it would look like. I couldn't even tell you how many components are in it. Yeah, just no chance. So I couldn't even tell you how many components are in, a buck converter. So yeah, for me, the learning phase is the essential part, and that's where I'm at right now. I'm on the learning phase. Once I've done that learning phase, move on to this planning phase, develop the schematics, go and develop the PCB CAD files, go and source the components, which hopefully I should know how to do. Get my PCB constructed, probably using GLC PCB, because that's the one that all the YouTubers have sponsored in their videos. So hopefully by then they'll be sponsoring this video. And then get the packaging, which I'm really excited about. Get the packaging actually developed, which should be excited. I hope that I can design it myself and then just get it printed somewhere. So after that, move on to the development phase, which obviously means getting the PCB actually manufactured and sent over to me, ordering the different components, getting the kits constructed, creating all of the PDF and video tutorials, which I think should hopefully be the easiest part of the project, which is a bit daunting. And then, yeah, get the packaging all developed, and basically from there, we should just be able to run a whole bunch of testing, and the whole kit should basically be complete. And then it's just about ironing out any kinks that may be in the kit. For example, if there's anything that can't be stored under certain temperatures, or if there's any low quality components that won't be able to be stored for a year. I don't know if that's the thing. Maybe like if I source a cheap battery, that might be a problem. Or if it's too small of a capacity, maybe you don't want to get it to the customer with a dead battery. So those are some of the things that I'm thinking about in terms of testing. But yeah, literally, once you've done with the testing phase, that's it. You're good to go, and hopefully I'll get a first in my assignment, and then also hopefully I'll be able to ship these in Amazon and eBay and elsewhere, maybe on my own website. And yeah, it'll be amazing, to develop this whole kit, learn a whole bunch doing it, and then in the end, even actually make money from it, and obviously help a whole bunch of students and hobbyists as well, both from watching me do all of this, from me documenting all of it, and then also from actually using the kit itself. So yeah, I'm very, very, very excited about this. Cool, guys. So yeah, that's it for me. Thanks for watching. Let me know what you think in the comments. Apologies about my voice. I'm a bit sick at the moment, but yeah, I was excited. I just finished planning all of this, and I'm like, look, I can't speak. I'm a bit sick, but it doesn't matter. I'm excited. So let's go. Thanks for watching, guys. Take care.